You saw nothing. Okay, hello, I hope everything is working. I'm sorry for the waiting screen being on so long. My internet has been struggling. But yes, today is C++ part 2. Part 2. I kind of forgot about part 1, but I'm gonna do a super quick run through of part 1, and then I shall continue with part 2. And I think part 2 is gonna include structures, function arguments, and linked lists. But there actually weren't that many lessons from this website. A lot of them were unfinished, but that's okay. There's still stuff to learn here, and I hope it helps someone get inspired to learn something new, whether it be coding or something else. And Sorry about the terrible stream quality yesterday. I hadn't realized that it was so bad, and then I kind of researched a little bit. I think it's because my bitrate is not great. It's not really stable, and my internet has been struggling to work, as shown today, especially on the red site. But yes, hopefully it works, and this is the last stream before I go on hiatus, so I hope everyone has a fun time here and learns something new. Good evening, hello! And I have some background music to play, but first, I'm gonna switch here. So I have some notes up here and some of the website here. So if you would like to follow along, I have the link in the red site in the description, and I have it pinned on the purple site in the chat. Yeah. But without further ado, I'm gonna start playing I hope the volume is okay. I can make it a little bit louder. Okay, there we go. I hope that's okay. And I brought back my little pen. I don't know if you remember the last time I tried bringing my pen. My computer crashed, but I just figured my computer's been struggling already, so it doesn't really matter. My internet's struggling, my computer's struggling, my bitrate is terrible, and I'm a streamer and a VTuber. Let's go! So, super quick review of what we have done part 1. So, we started off with Hello World, which is the first program. You have to include this. So you must include the directive, the first line of code. You have the main function. So main is a function. Your code goes here, and the int indicates that the main function will return an integer. So it will return 0. And I'm gonna pull this up. Hopefully chat is not blocking it. And I can show the solution. So here we have that directory. We have the main function, it will return 0. And we have it couting, in other words, printing out hello world, and then an end line. So that'll be the next line. And then after, we have variables and types. So variables and types are sort of modifiers. They tell the computer or the code what type of data you will be storing. And I lost chat. Hold on, my bad. What is wrong? Hello, thank you for hopping over to the purple site. I lost chat. Where's my chat? I have too many tabs open. This is fine. There we go. I brought everyone back. Hello! Sorry if I didn't see. Okay. Yes. Everything's working, I think. Yeah, okay, so variables and types are sort of like labels or modifiers that tell what type of variable you will be storing. So it can be strings or like letters, or an integer, so a number that is made up of the maximum value of 4 bytes. And you define variables by having the type, and then you can name the variable something, and then you can have it equal something. Right? Oh, enumeration requires the use of the key enum. I actually don't know this. I forgot. The general form of enumeration type is this. Once a new enum name is a enumeration type name. Names are separated by commas. Oh, okay. So you can sort of create a type, I believe, with the enumeration. Color. Yes. Yeah. And then here, the example shows a bunch of integers. So the integer type, some calculation, subtract, add, and then multiply, and then you see out the value of a. So it will print out an integer a. And let's see this. So this exercise, you will create a program which prints out the sum of these numbers. So I guess they give you these. And if you notice that int cannot be, well, it can be a decimal. It will just truncate the decimal. So use a float or a double. And then you can add them all together and then output the sum, which is the type of, which is labeled as type double. Okay. Next we have arrays. So arrays are sort of lists, right? They hold value. Suppose you need to store 5 marks of a student. Yeah, so they're kind of like lists. It's a group of the same type of variables clubbed together. So here we have an array, so it's got five values in the list, so 5 sort of bullet points in the list, you could say, comparing it to bullet point. And then you declare that each value in the list is an integer, so it's a number. Then we have marks, which is the name of the array. So it starts at 0 and goes all the way to 4. And then you label it. This represents the where you grab the information. So this is the size, and this is where on the list. So let's say you have 5 bullet points. So if you have 0, that means that is the first bullet point, and that can get a little bit confusing if you don't know how to, if it's not used, like you're not used to starting at 0 or starting a value at 0. You keep going. You can also define it like this or like this. You can also output or print out the value of an array. So in this case, mark 0 would print out 96. And there's a for loop that prints out all of the values in the list or the array. Suppose keys are... Oh, so you can declare it as characters like this. You can declare an array all in one line if you want. So let's compare the solution. Change the program in the button in a way that so that initiates the key array with values of this, and it prints the third element. So here you declare the array, and then you want to print the third element, so you start 0, 1, 2. So it will print out D. And yeah, so a good way to sort of remember what you are going to print out is to say, I want to print out the third element. So you remember 3, and then you just subtract 1. So that will be your element you put out here. Okay, what's next? Arrays. We have strings. So strings are used for text values such as words or sentences. So just like you can put numbers into an integer, if you declare something as the string variable type and you can name it something, you can put an entire text phrase, and you can even print out that text phrase. So let's go up here for the solution. Change the program in the bottom in a way so that it declares and initializes a string variable and outputs the text. I just learned something about strings without the quotation marks, followed by a carriage return and line feed. So we have this. We declare a string variable. Oh, wait. Declare that string variable. You type, I just learned something about strings, and then you can print out that variable. So just like that. So here you declare it equals a value and print out the value using cout. Then for strings, you go to if else. So if else is a statement. So it's sort of, you can compare something with another something. And if it is true, or if it is correct, a correct statement, then it will continue in these brackets. So it is when you only want to run a block of code if a condition is met. So here we have the if. It has two brackets to open and close it. Then you have your little condition. So in this example, if number equals 4, so if the value of number equals 4, it will go through this statement and print out the one I searched for. This one prints out if the number is even. So this is the modulus operator, so that's the remainder of something. And if this number equals 0, so that means it is able to divide by 2 without any remainders, so that means it has to be even. Then you output the number is even. So an if-else statement is if it is not even, so in this case, this is the condition of checking if the value num is even. So if it is even, it will print out the number is even, and if not, it will say the number is not even. And you can have if else, and then else. So it will check it from top to bottom periodically. So it will first check, is it divisible by 2? And then if it's true, then it will go through this and skip all of that. If it is not divisible by 2, it will check if the number is divisible by 3. So if this is true, it will output this, and if not, the number is not divisible by 2 or 3, then it will output a bad number. So we have this sort of exercise. Here you're given a list of, or an array. So a list of ages. You want to check if they meet the conditions of being called a child, adult, or retired. So the for loop will go through the list of ages. The if statement will check if it is under 20, so that'll be child, and if the age is in between 20 and less than 60, so if someone is 20 to 59, then it will output adult, and if else, it will say retired. So if else, and then we have for loops. I wish they went over for loops before all of that, because it's a little bit backwards. But for loops are loops that repeat for a certain condition, right here, and then you can use this to increment that condition. Let's see. So if you know the exact number of times you want to repeat a certain line of code, then you would use a for loop. And there are 4 parts. So you have the initialization, so that is sort of your counter. You have your test condition, so that's when you want to stop or jump out of the for loop, and then you have your update. So usually you would subtract or add the initialization depending on how many times you want to loop. So here it will print hello C++ for 10 times because it starts at I is equal to 0. So that is less than 10. Then it will print this, and then it will increase I, so now I is equal to 1. So 1 is still less than 10, it will print that, and now I is equal to 2. Then it is less than 10, so it'll still print that, and it'll go all the way till I is equal to... So after I is equal to 9, it will print, and then it will increment. Then it can't go anymore because 10 is not less than 10. 10 is equal to 10. And then, yeah, there are also different ways to write the initialization. So here we just have the condition and the update in the code, or in the for loop itself. So we have the initialization outside, then we have the statement that you want it to do, then you have the update. And here for loops are great for iterating through an array. So like going through a list or going through an array and printing out each element of it. Yeah. So here we have int I, so we have initialized I as an integer, then we have I is equal to 0. Then it will keep going through this section of code until it is the letter, or the number 20, not the letter 20, the number 20. So it will keep going through this for loop 19 times, No, not 19. 20 times. 20 times, because it starts at 0. My bad. So, yeah, 20 times. And then it will print out I. For loop. Okay, we have while loops. Also a very interesting way to place this. We're almost done with the review, I promise. I know this is like information dump. But almost done with the review. So while loops are also loops, but this time you usually have a condition to break it, but you don't exactly know the exact number of times you want to iterate through that loop or repeat that loop. So use loops to program and repeat the execution block of code. While loop will repeat a statement or a group of statements while a condition is true. So you may not know exactly what or how many times you want to repeat something, but you might know the condition you want. So here's an example. You have search is equal to 5, given is equal to -1. So if search is not equal to given, in this case, it is not equal to given, so that means this condition is met. There's a lot of nots. So since 5 is not equal to -1, and it's checking if they are not equal to each other, this will go in to the while loop. It will take in the given, and then print out, thank you for your guess, and then keep going. So it will keep taking in this value, I think, unless it becomes equal. So let's say given is now 5. So you have 5 is equal to 5, then it will either jump out of this loop, or it just won't execute whatever code's in here at all. Let's see, try to print all the numbers from 1 to 20 in ascending order using a while loop. Let's quickly review the solution. So we have a counter and we have a target. So the counter is the value that keeps going up, so it starts at 0. And we have a target, so we want it to print all the numbers to 20. So because 0 is less than 20, it will go into this while loop. It will increase its value, so it goes from 0 to 1. It will output 1. And now counter is equal to 1, so we'll keep going to this while loop, because 1 is less than 20. It will increase to 2. Print out 2, and then keep going, and it will keep going until counter is equal to 20. Yeah, because it will still print when it's 19. Counter will equal to 20. So once counter is 19, it will go one more time through this. Counter will now equal 20. It will output 20, and then it would check this condition again, but because 20 is not less than 20, it will not go through this while loop. Okay, functions. Functions, similar to math, is a collective of statements that is designed to perform specific tasks. So functions take in inputs, then it processes an output below, so it returns something. Actually, I believe this is correct. The int main is actually a function. Yeah. And it returns 0, which is also an integer. But here we have the function type. So in this case, it is an integer. Function name. So we have square numbers and the parameters that you want to take in. So it's going to take in a parameter, which is an integer, and it will assign that parameter the x value. So in this case, we have input is equal to 9. This function call will take in 9. It will go up here, have 9 as the integer x. We'll have 9 times 9. It will return y, which I guess is 81. And then output is now equal to 81. Yeah. And here's another example where you call Selena. You will put the name here, and it will assign Selena equal to the name. Then it will say hello, and then comma Selena. Let's look at the example, the exercise. In this exercise, you will create a function that prints out the sum of the given variables a, b, and c below the given code. So here we are given these integer values. You want to make a function, so you name it addition. it will take in these three values, which are the integers right above it. It will assign a as equal to a, b is equal to b, and c is equal to c. Then it will have this operation, which is addition, and then it will output that addition. Okay, we're almost there. Pointers. This is where we last ended on. It was a bit tough, but pointers reference a variable in memory. So if you remember that game that I played called Human Resource Machine, it was not, it was about lower level programming, but in some sense, it is similar to pointers in terms of pointing at memory location and memory addresses. Pointers are basically a reference to any variable in memory. They are pointing to a memory address where a variable is stored. And I am not great at pointers either. So let's look at this example first. So here we have the integer a is equal to 5. Here we are going to create a new pointer type and initialize it with having it equal 0. Now, they're going to output something. Now you can point to it. So if you have and a, b is now equal to the address of a, or wherever a is stored. And b is initialized, now pointing to memory address b. So when you initialize it, it still points to a memory address, I guess. And then you have b is equal to the little and. What do you call this? And symbol? There's a real name for this, and I forgot it. The and symbol, and now that points to whatever address a is being stored all the way up here. So a memory address is stored here, so you can find the memory address by putting an and in front of it, and b is pointing to the memory address this. So this is how you declare a pointer, but because b is now equal to the memory address of a, this value, b, is equal to this, however this value is different. Ampersand. Yes, ampersand! Thank you! Thank you. Ampersand. I think that's right. That sounds very familiar. Ampersand. And the value of the area B is pointing to, the value of the area B is pointing to this. So the asterisk B will get the value from the address. Hold on. Okay, asterisk B will get the value from the address B, points to the value of A. Oh, okay. I see. So if you have the asterisk, the star, you have the star B, it will point to whatever value, or it will point to sort of the memory. So because B is equal to the address of A, it will say, oh, I'm gonna go look at the address of A and then see what's in that address of A, which would be 5. And then so on and so forth. Now modify the address B is pointing to effectively changing the value of A. So because there is an asterisk B, which is sort of connected to A, if you change that B value, it will equal A. Yeah. Void pointer. So void pointer in C++ particularly. So here's where the plus plus of C comes from. Because in C, I don't think you can. You can explicitly typecast it. In C, you can assign a void pointer to a non-void pointer without using a cast to a non-void pointer, and however in C, you can explicitly cast type it. So here we have a void pointer and a character pointer, and you have them equal to each other, and then you have that typecast. So you can essentially typecast this void. Yeah. Since this is the last lesson before I switch over to the new stuff, and this is quite frankly the most confusing one, at least for me, I am gonna go over to my notes and try to draw out a little something. There we go. So we have the integer a. I'm just gonna write a as the integer. Then we have the address of a. So I'm gonna try to draw the ampersand. That's not. You know, how do you draw an ampersand? Oh, that's just an 8. And here's where you see, I'm not an artist. Like there. Oh, okay. Like that. So we have the ampersand of a. So that is the address of a. Yeah. Oh, here's the integer. I probably should have... Wait, let me redo this. Hold on. Sorry. I should have kept it all the same caps. With that, we have the ampersand of a, so we have the int. This refers to the address and when you have b is equal to that, b is now equal to a's. Oh, b is now address a. I should write address a. I missed a value. My handwriting is lovely, don't you think, everyone? And then, so now b is equal to the address of a. B has its own... Oh, I should write the ampersand b, which is b's memory address. So address b. Yeah. So a right now is still whatever value you declare it. However, because star b is now pointing to address a, which is now looking at a value of a. If you change this value, it will change the value of a, or the integer a, all the way up here. Yeah. I'm gonna keep that there for now. If I remember, last time I struggled a bit on this exercise because it made me do a void and I didn't understand voids too well. Indirectly access and modify the value of n and create two pointers, p1 and p2, for the given integer, with p1 being a void pointer and p2 in the int pointer. p2 must be assigned to p1, indirectly increase the value of n. So here we have declared the integer n. We have the creation of the two pointers, so you have the void pointer 1 and the integer pointer 2. Then you can have the void pointer point to, or void pointer 1 equal to the address of the integer n. Then you can have the integer, or the pointer 2 equal to whatever n, or whatever p1 is referencing, the address. Yeah, wherever p1 is referencing and that value that it is referencing to. So similarly, like over here, you say p2 is equal to p1, which is pointing to the address of n, which is then pointing to the value of a. And here you can increase the value of n indirectly, and then you just output n. Yeah, so pointer, the address of A, and then you have this, which points to the value of P2, and then you output, I think. Yeah, I'm not too great on pointers, but that's my best way to explain it. Okay, here's the new stuff. Sorry about the information dump and the quick run-through of many lessons. I think this one only has 3 lessons because a lot of these lessons here on the side are actually unfinished, or they're not, or people haven't like created these yet. So I'm gonna move my notes a little. We're gonna call this, pick a different color. Let's do a lighter blue. Is this still visible? I think so. Yes, we have structures. Structures. Ow. Oh. So, let's go through this lesson. What is a structure? If you start programming code in C++, you'll sooner or later be faced in a situation in which you need to store coherent data in a structured way. This is where structures come into place. A structure is basically a user-defined data type, which consists of other data types like integer, character, or char, int, char, and etc. So, defining a structure. This is how you usually define a structure. You start with the directory, I think. Then you have a structure and then my own structure. So you define it sort of as a structure type, if that makes sense. Like, does a structure type exist? So it's kind of like functions, in a way. Then you call it structure. The keyword struct followed by name, followed by braces containing the data you like, followed by a semicolon. Okay, so here are the braces, or the curly brackets, braces. Then you have an integer, or 2 integers with a name, and a char, and a boolean type, which is like a true-false thing. A true-false variable type. So you have a structure, you name it something, and then you have these variables and types within the structure. So using a structure. Oh, there's no explanation. Lovely. That's okay. We don't need one. So here you have the declaration of 2 structures. Yeah, declaration of 2 structure. Oh, you have... Wait, no? Oh, it's a continuation of this. Oh, I see. So, you have the definition of the structure above your int main. Then you call that structure and you say demo1, which is the variable. And so this is sort of the type, I guess. So when you create a structure, you call it struct, but then this also sort of becomes a variable type, I think. A user-defined type. Oh, yeah, okay, structures. We should add that into the notes. So user defined data type. So you're sort of making your own variable type. I see. Data type. So you made your own data type called my own struct. Then you created 2 variables based off that. And then you want to change... Oh, it's like almost like a nested data thing, data type. So once you have your own data type, you can retrieve values in that structure. User-defined data type with values in that data type, or with multiple. So with multiple. I don't know how to spell multi. Okay, we're called multi. Sorry. I swear I'm not pretending to be dumb when it comes to spelling. I just can't spell for the life of me. It's a struggle with multi variables. Variables. Okay. With multivariables where you can define a value. Multivariables and then many values. Yeah. So here you are sort of assigning the variable demo1, and within that variable, you are assigning property 1 is equal to 1. So with the demo1 structure, you have property 1 is equal to 1. And then you have property 2 is equal to 2. 3's A and property 4 false. And then you can set demo2's values. So you have demo2, property 1 is equal to 3. 4, B, and true. Then they are printing out what type of values they have within this structure. Yeah. So you have demo1 is equal to, and then it prints out the value of property 1, 2, 3, and 4. So you would print out demo colon space 1, 2, A false, and then it would output for the second one demo2 colon space 3, 4, B true. And there's a comment on the output. However, it is good to note, like I said, Boolean is a 0 and 1, so false is just 0 and true is 1. So well, that's how the computer reads everything, you know, ones and zeros. So false is 0 and true is 1, or good is 1. And here is the exercise. I've not done this exercise, and quite frankly, I'm not good with structures. I have not learned this in a while, but if you would like to contribute if I'm struggling, I want to try it myself just for a little bit, but if I'm struggling, I will ask chat for help. So yeah, be on standby to help me, which will probably happen. Create a structure named person with the following fields. Name should be string. Okay, so age should be an integer. Do programming should be a Boolean. So let's put an example here. I always like writing out my code in not coding language first, or just to see sort of like a flow chart of what I want. So here we have a structure. We're going to call it person. And within this structure, there should be a name. So we're going to have name, have age, do programming. I'm just going to write it like that. You want to declare two objects. So you want two objects that are this sort of person structure. So there's P1 and P2. So how do I do this? I'm gonna write P1 and then P2. Sort of like this, and then draw a bigger box around it. I hope this makes sense, everyone. And then I'm gonna have this one equal to, so it says Alice. And write Alice, age 20. And programming? Yes. So guess Alice programs. So we're gonna write true. So you're assigning these values with this. And then you have P2. We have Bob. age is 18. And false. So Bob does not program. And then you want to print out this information with that. See out the information in the scheme. Name is equal or less than? Huh? Example, Tim 22 by getting values from your structured objects in the scheme. Oh, okay. So you want to print it out, or want it to print. I'm gonna put print. Hello, and thank you for the sub. Print. So they'll have name. So it'll be, how would that work? You want it to be an example. I'm gonna write an example. So Alice 20. Then what do I put this? True? Alice 20. I don't know where to put the true. It kind of doesn't really give me much information on it. Okay. So I am going to start the exercise. So first, let's create this using... Whoa. What happened? Oh, it's right here. Lovely. It helps me out a little bit. So we're going to call the struct person. And don't forget the brackets. I actually don't like having my brackets or the first bracket on the same line. I like putting them all in the same spot. So I prefer it this way. But you can do whatever, as long as it works. And it's readable. I'm going to have it like that. And name should be a string. So we're going to declare string name semicolon int. Oh, did I spell string wrong? string. No. Interesting. Usually when you declare a type, it will highlight it or color it differently, so hopefully that's correct. Oh, my big head is blocking the whiteboard. Oops. Okay. We have the integer. And then a boolean. 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 Or is it oh, it's bull. I don't need to spell the whole thing out. So a boolean, and then type do underscore programming colon. So right now, I am declaring it right here. So I'm doing, oh, you cannot see that. There we go. I'm doing this sort of part. Wow, that's terrible. I'm doing this part. Can I draw a circle? Apparently not. I cannot draw a circle. I'm doing that part. And then time to move on to the second part. So I am going to declare P1. So similarly, you call upon whatever name you called your struct. So I called it person. So here I would call person and then P1. And then I can do person again. P2. Yeah, I think so. Why did my music stop? Hold on. I don't like sitting in silence. The silence eats away at my soul. Alright, there we go. So here we have that. And then I will call it the P1 dot. And then I called it name. is equal to, I think I have to put the quotes. So Alice, semicolon. Then we have P2 and then age, or P1 dot and then age. Semicolon. P1 dot do programming. Did I spell that right? You know what I could use? The Control-C and the Control-V. And then it should be true. Yes. I think that's how you do it. Yeah, that looks right. Intense programming. Even the BGM held their breath. Oh, I put it in the wrong spot. My bad. That's fine. I'm gonna put... Yeah, I'm just gonna put P... Okay, I'm gonna ignore these comments. No, okay, not that. No, stop. Here. There you go. You have P2, name, Bob, P2. I put a space. I don't know if you can put a space there. 18, a comment actually. Print out name, so it would be like P1 dot age name, and I'll do that twice. And this time I will change it to simply P2. Yeah. I think that's correct. Oh wait, P2H. And P1H as well. Yeah. Does that look right, everyone? I wish I could make it bigger. I don't know how to make this window bigger. So let's think about this again. So we have our structured, this is where we declare our structure. We have the string name, so that's name, integer. We have a boolean, where we declared do programming. Should be bool, int, string, yep. Go down here to the main, to the int main section, where we declare P1, P2 as the type of structure that we declared. Then we have P1 is equal to Alice, age is 20, and then do programming is true. We do the same for Bob, 18, and false. Then we output their name, so we refer back to P1, and then the P1 age. And then we do it again for Bob, so we have Bob, and then we output 18. Yeah, I think that's right. Let's see if this is correct. Warning! Oh no, a bunch of errors. Okay, oh, I see. I forgot to close the... Yeah, I miss the quotation mark. I failed my coding class with Java, so I have no clue. You know, I too failed my coding class in Java. I don't know how to code in Java. I barely passed my C++ tests previously, but it's been years, and ever since I finished those coding classes, I vowed to never take one again. Or not in the traditional sense. Like, I'm willing to learn about coding, but also, I'm tired, and I don't want to do coding anymore. Sometimes. Expected semicolon. Oh, and I forgot a semicolon here. Make sure to add the semicolon after your structured declaration. Oh, I got it. Okay, so we can see here. That's a little dark. Can I cancel? We have Alice and Bob. This is all we need to print out. I'm curious as why they made us do the do coding boolean. But yeah, we got it correct because we printed out their name and their age. So what's next? Okay. Where do I go next? Function arguments by reference. Let's make a new section for the notes. And change the color to a darker blue. And I'm gonna move this up a little. I left a speck there. That speck is gonna annoy me. There we go. Here we have function arguments by reference. Function arguments by reference EE. Okay, I don't like that C. C. There we go. And of course we have to draw a smiley face. Here we go. So, let's start. In C++, it is the same principle as in C, assuming you already know pointers and functions. Well, I'm not great with pointers, but I guess functions are okay. And now we know about structures. So, you are aware that the function argument are passed by value, which means they are copied in and out of functions. But if we pass pointers to values instead of the values themselves, this will enable us to give functions control over variables and structures of the parent functions, and not just a copy of them, thus directly reading and writing the original product. Let's say you want to write a function which increments a number by 1 called addon? This will not work. So, let's break that down a little bit. Assuming you already know pointers, you are aware that function arguments are passed by value, which means they are copied in and out of functions. But if we pass pointers to values instead of themselves, so it's sort of passing pointers to values. So it doesn't change itself. Like passing pointers to values. Does not change itself. And we'll put one underneath. So doesn't change self. ELF, self. That looks really bad. Self, yeah. Let's say we want to write a function which increments a number by 1. Okay, this will not work. So let's see what's going on. Oh, they're using printf. I don't like that, because I don't really understand printf too well. Printf is like cout, I think, but with other things. So we have the integer n. So you print out the integer n before it changes. Then you pass n through this void function. Then it will increment. And then it's supposed to increment. However, because n is a local variable, it only exists in this sort of function scope. So there's sort of function scopes to deal with, or how do I say it? Groups? Function groups? So the scope of something is an area. Let's say it's an area. You have the value of n, but you want to use n outside of that area. You can't exactly just grab n and use n outside of that area. Let's say there's a dog in a glass house. We'll have the dog kind of represent n. You want to bring the dog outside to this grass area, but you can't just go through the glass or go through the walls to just grab the dog outside. You have to do other things. before you can actually bring the dog outside, because the scope of where the dog is running right now is inside the glass house. You can't walk through walls, so you can't just bring the dog out. Yeah, I think... Does that make sense? I don't know why I used the dog, but I kind of want a dog. Okay, unrelated, but I shall continue. However, this will work. So we have the same sort of declaration, and in this case, you are passing the address. So if we go all the way back up here. So remember that the ampersand, and the integer points to the address of A. So we can pass through that address here. Then we have this pointer, so that it has the value of the address and then points to the value of n. And here it will increment. So that will work. So I guess going back to... Okay, the dog analogy does not work here. How do I explain this outside? We have something. Yeah, okay, the dog analogy just falls apart. Oh no, poor dog. I feel bad. I shouldn't have used dog. I should have used like a rat or something. And thank you for the sub, by the way. Kuhaku? Thank you. The dog analogy fails. How do I think about this? Oh, you know what will fix this? Magic powers. Okay. So you have a dog in a glass house, and instead of trying to reach the dog, you use your like telepathy and your magic powers to sort of point out where the dog is. So you're outside, you're looking at where the dog is. You sort of have magic that can point where the dog is. And then because you have this magic, once you can bring its spirit. Ah, that's a good way to say it. Instead of its address, you can bring its spirit outside of that sort of scope, and you can sort of interact with the dog and the dog's spirit. Does that make any sense? This is why I'm a failed engineer, everyone. Okay, I shall keep going. Why do my notes start... Why are they crooked? Why is there like a diagonal line here? Okay, hello Mariachi. I think I'm losing my mind, but what else is new? Nothing. So, the difference is that the second version of the add-done receives a pointer to the variable n as an argument. And then it can manipulate it, which it knows where it is in the memory. Notice that when calling the add-done function, we must pass a reference. So the ampersand, the and sign, the ampersand sign, to the value n, and not the variable itself. This is done so that the function knows the address of the variable and won't just receive a copy of the variable itself. Okay, so is the volume too loud? Am I too loud? I just realized the music's a tad bit loud. I hope it's okay. So let's add a little map here as well. So you must reference that variable. No, you're good? Okay. Well, I turned it down for nothing. I turned it down preemptively. My bad. Okay, I turned it back up. So, how do I map this? We have an integer. Can't touch. Can't touch this. You have to sing this part. Okay, you can't touch this. However, if you have a reference, so we have the ampersand, and. So this is sort of the magic part, your magic, where you can reference the spirit, or in this case, referencing n. Or referencing the address of n. So it references the address of n, and then you can pass that in to the function argument and change the n. So we can say that this can go through. Oh, I guess I should star this. So this will point to the value n. Right? Yes. The value of n. So you take that. You take the ampersand of n. It will go through. It will change into the asterisk n. And here you can change the spirit of n, which then changes the value of n. Oh, I'm blocking it. My head is too big. Hold on, my bad. Okay, since my head was too huge, I have too big brain, and I'm too tall. I'm definitely too tall, and my head is too heavy for my shoulders, and it's too big. Definitely not smooth at all. So here we have n, which you can't touch. Then we have the ampersand of n, which references the address of n. So this will take in that address, and then go to the value of n. So I'm sort of gonna draw an arrow that goes this way. So it goes to the value of n. So here we go, ampersand of n to the asterisk of n, where you can change the spirit of n, which actually just changes the value of n. Changes value of n. And then now you are happy. Yeah. Pointers to structures. Let's say we want to create a function which moves a point forward in both x and a direction. Yes, this is an a. X and y directions, called move. Instead of sending 2 pointers, you can now send 1 pointer to the function of the structure. So here you're declaring the structure. Yeah. Then you have, the function. This is not a structure. You're declaring the function right here. Then you are taking in a pointer value, and you are changing it. Oh, wait, I see what's going on. So this one, you have a structure with 2 values within that structure, x and n. So you can just point to the entire structure and then change the individual values inside that structure. Yeah, I think that's what's going on. However, if we wish to dereference a structure and access one of its internal members, we have a shorthand syntax for that, because this operation is widely used in data structures. We can rewrite this function using the following syntax. So you want to dereference something and access its internal member. You can use this little arrow syntax. That's a nice point to make. So you can access so you can change values within a structure with 1 pointer. Let's write that. Change values in struct, struc. Change values in struct with function arguments function argument and one pointer. And one pointer. One pointer. Yeah. Next, you can write that you can access internal access members of structure. Access members my handwriting is terrible of structures. Do not mind the spacing. Access member of structures and my enormous head. Hold on. Yeah, there we go. Access member of structures with this symbol. And yeah. Okay, let me make the symbol a little bit neater. Oh, wait, I can draw lines in this? Okay, I didn't know I could draw lines in this. So here we are with the exercise, the example. I hope everything makes sense so far to an extent. I know maybe for the first time, if you've never seen this stuff before, it can be intimidating, but I hope at least one thing sort of makes sense. Whether it be the analogy to the dog or how it's actually written, I hope something makes sense. And I hope my handwriting is not too bad. Not absolutely terrible. But if something doesn't make sense, feel free to chat it. I will try my best to explain it again. But no guarantees, because I'm not a great teacher, and like I said, there's a reason why I call myself a failed engineer. Yeah. So, for the example, why is it moving diagonally? Okay. Go all the way up here. Example. You want a function called birthday. So you want a function, I'm just gonna call it func. Funk. Funk. And then you want something called birthday. Which adds 1 to the age of a person. To the age of a person. Oh, so this is sort of based off the previous one. Okay, so I wonder if I can grab this and copy it. Let me try that again. Like that. Can I do this? Yes, I can. Hold on. Let me move this really quickly. Oh, I can remove this part though. Goodbye. So I believe when they mean by person, they're referring back to this example previously. Function, so you want to look at that, and then you want to add 1 to age. You want to add 1 to age. ++. Yes. So this should be like now 21. So this should be like 21, and this should be 19. So I'm gonna start the exercise. Or is this different? Oh, it's got the printf. I don't like that. Oh, it's John. I guess they gave us different ones? Well, it's entirely different. Okay. So, it's a bit wrong. That's fine. So here we have person. So this is the structure. Oh, this is the struct. Okay, I see. So they're defining the struct right there. Then they are giving the function declaration. And then I have to write the function the function within the function right here. So here we have, let's scroll up here for a better reference. Here we have that. Okay. We add the brackets. Get rid of this semicolon. We are gonna point to P, and then you can do parentheses P pointer P, so you have asterisk, the star, and then we can increment, so you add the plus plus, which will increment by 1, and I think is that it? Oh, I need to call this function argument, so similarly to this. Down here, so if John is age 27 right now, then we can call this, so we call it birthday, parentheses, do you also do the ampersand John age? Let's try this and see what happens. I have a feeling this might not be correct, or it could be correct. I'm just gonna run it. Converting a string to a constant char? Oh, I didn't even realize. String. Yeah, a character. It can only be a character, and the reason I got this error is because... Yeah, the reason I got this error is because it gave us a string, so I don't know why they had it as character in the first place. That's okay. And then the second error is cannot convert an integer pointer into person. Oh, the person type. So this is an integer, which makes sense. And how do I call, or is it this? Do I do this? I think it's this. Let's try that. A lot of error. String. It doesn't exist. What? String is not a data type. Hold on. I'm gonna come back to this really quickly. I think I have to add that. What? Oh, did it get rid of everything I just did? Lovely. It did. That's okay. We can do this again. Hello. Thank you for subbing. I appreciate it. We can do this again. Remember, one setback is nothing. So I am going to have star p dot age plus plus semicolon to finish that, and we are gonna call John properly, right? Oh, changes to string. I hope that works. Please do not let me put in a character. I would be a bit sad. A bit saddened if that were the case. Okay, and then I will call the function argument, which is birthday. Yuck, spacing. Okay, fix the spacing. And then I will ampersand, and then John. For the variable John, and that. Const char cannot convert What's wrong here? Const char to string. Okay, I don't know why that is. And it's very interesting how this has nothing to do with the lesson, but that's okay. Okay, let me think about this. String name. Oh wait, this itself is a pointer. Oh! So this holds the character of the name. But you can't change the name because it's holding the address. So it's holding the address of whatever name is. Then do I just do name? This? Name was not declared. Oh. String. String name. Null is 28 years old. Happy birthday, Null. So the name is not reading out correct. But I could just get rid of the pointer and just do this, I think. And I can just do John name. John period name. I think. Let's try that. Service output, lovely. Alright, does anyone have any clue as what to do with this? Your handwriting is neat and clear. Oh, okay, thank you. Really? I think it's pretty bad. You know, different sizes lurk. Alright, thanks for lurking. I hope my bot works. Okay, there you go. Let's see. I know the age part is correct. I know that it is pointing correctly. Happy birthday. It's not my birthday. I wish it were. But thank you, even though it's not my birthday. Char was correct. You want to use... But if you want to use string, you need to include... Oh, okay. Let's try to do it the correct way, which is char. Char, pointer, and the name. But the thing, it's pointing to... Wait, what did I do? I did get it correct. I ran it twice. Okay, I need to reset. Hold on, let me copy and paste this. Is now cast aging spell. I died internally. I incremented the value twice. Oh wait, I called... Oh wait, no I didn't. I'm fine. It actually calls it for me. Yeah, there we go. Char's correct, but if you want to use string... Okay. Thank you. I don't know what happened. Why didn't char work earlier? I am a bit confused, but that's okay. I think we got it this time. Or maybe... Hold on, let me reset this. Let me copy this. And I'm gonna reset it. Wait, what did I do wrong? The first time. Because this points to the value of name. Sure. Yeah, sure. Okay. Or is it because of the what I added here, the IO stream and the namespace std? Dynamic allocation. This lesson actually doesn't exist. It is merely just there in case anyone wants to contribute. Apparently, if you are an expert at coding, feel free to contribute. I think this is a great resource. They also have like other things, but I'm not good enough to code anything. I'm still learning C++ myself. But yeah, thank you for the stream. I missed your message. I'm so sorry. Thank you for the stream. Sadly, I must try and sleep. I'll watch the rest tomorrow. Forgive me, Barry. No worries. And thank you for coming. Thank you for chatting, of course. At least John got his birthday, even though we're still clueless. Birthdays are nice. Except it reminds me of how fickle life can be. And existentialism. And what am I here for? And each year I get older. And what am I going to do with all this time? What do I do with my life? You know? Though there actually isn't a dynamic allocation, there aren't any of these, actually. The next one is going to be linked lists. So I will still go through it. This is recursion. I hate recursion. And I'm happy that I don't have to do that. Linked list. And I think this is the last one that actually exists. And this one is a long one, so sit tight. Well, I try to finish this. Yeah, okay, linked list. I want to change the color. I will change it to a red. Maybe red's too strong. A pink. Pink? Or can I pick the color? Pink? Oh. Yeah, I know coding. Let me just copy this. You know what they say, coders are actually just very good at Googling things. Linked lists. I actually haven't learned linked lists at all, so this is gonna definitely be a struggle for me. But I'm gonna try my best. See how that goes. Draw the smiley face. You know, since this is the last one, I'm gonna draw a blueberry. Just really quickly, you know, just a little blueberry for good luck. And of course another smiley. Okay, linked lists. Linked lists are the best and simplest example of a dynamic data structure that uses pointers. More pointers? I guess everything uses pointers, huh? It uses pointers for its implementation. However, understanding pointers is crucial to understanding how linked lists work. So, if you've skipped the pointers tutorial, you should go back and redo it. You must be familiar with dynamic memory allocation and structures. So, a lot of pointers. Maybe I'll put in just a little bit, a little note, understand pointers. Stand pointers. You should learn JavaScript next. Ooh, yeah, maybe I should. I'm always scared about these sort of streams. For some reason, I love doing them, but they also make me so anxious because it really shows how smooth brain, I mean, definitely not smooth brain I am. JavaScript is very interesting. The first language I actually technically learned was Java, but don't ask me to do Java because I don't know. I failed that class. That was also a very long time ago. Okay, continuing. Essentially, linked list function is an array that can grow and shrink as needed. From any point in the array, linked lists have a few advantages over arrays. Items can be added or removed from the middle of the list. There is no need to define an initial size. However, linked list also has a few disadvantages. All right, so a little trade-off there. There's no engineering or computer science or science in general without some trade-off. There is no random access. It is impossible to reach the nth item in the array without first iterating over all items until that item. Really? Really? So you have to go through the entire list? That sucks. This means we have to start from the beginning of the list and count how many times we advance in the list until we get the desired item. Dynamic memory allocation and pointers are required, which complicates the code and increases the risk of memory leaks. And segment faults. This really screwed me over when I was learning, but at least I'm not in class anymore. The linked lists have a much larger overhead over arrays, since linked list items are dynamically allocated, which is less efficient in memory usage, and each item in the list also must store an additional pointer. So we have advantages and advantages. So there's no need to define initial size, and items can be added and removed. Added and removed. Added or I guess. Added or removed from the middle. The way you can't do that with arrays, because once you declare the size of an array, it kind of has to be there. Removed from list. The music stopped again. Let me restart that. I don't know why it does this. I hope it hasn't been off for too long. Yeah, okay. Everything's back. Yeah. Everything's back. Sorry. Sorry for the scuff. No need for initial size. Don't need initial size. Don't need initial size, and then we have disadvantages. Disadvantages. So must iterate through list. Must M-U-S-S-T. Must iterate through list. To get items. Dynamic memory allocation complicates code, or I should say complicated. Complicated. And say risk memory leak and segment or seg faults. Risk mem leak. And seg faults. So seg faults. LTS. Yeah, there we go. Then the last disadvantage is have much larger overhead. So less efficient in memory. Or more memory storage, so less efficient for memory. In M. Oh, or I can just abbreviate it as M. I don't like that spacing. Let me fix that really quick. There we go. So what is a linked list? Ooh, and this lesson has graphs. Oh, I didn't mean to zoom out. There we go. My bad. What is a linked list? A linked list is a set of dynamically allocated nodes arranged in such a way that each node contains one value and one pointer, so it has two things. Oh, the pointer always points to the next member of the list. If the pointer is null pointer, then that is the last node of the list. Okay, so here we have the head, which has a value, and then we have the inside of that list, which has, or the head, which has a memory value, I think. Yeah. And then we have where the value is, or the actual value of that node. And then within that node, it also points to the next value. So it has a pointer to the next. So I am going to, we'll have like a literal head for as a representation. And it has some sort of value. And it is a pointer, I believe. Then we go here, then we have a value. So I'll just put like 1 as the value, and then some memory location. So next address. Then I can use a different color. Can you see this color? That color's not the best. I'm gonna do this and have that point to second value, which will be, I'll just put 2, value 2, and we have another one that will represent the next address. And that one will point to another value and so on. So like that, and then whatever. And put, oh, I can put tail. I should put the tail. So where should the tail be? What's a tail for something like this? I put a little head. How about like a foot? I mean, bears have tails, but like they're also circles. So I'm gonna put a foot. A square block foot. And someone's legs there. There we go. That looks normal. Then I'm gonna put end. That's an N. I need an N, end. And it has some sort of location. Yeah. So let's define a linked list node. So here we have a structure. Structure. Oh, okay. So node has structure, then we have the integer value and struct node, and it points to next. So we define a node, and within that structure it has 2 values, and this will recall this struct node next. A linked list is held using a pointer. Oh, I see. So here we have the structure, then we have that node at that value. Oh, I get it. Okay, so here we declare like this entire thing. Let's say we're declaring this entire caterpillar thing. And then we have the value, which is the integer. Then we have the struct node pointer next, which refers to this box. So the orangish yellow boxes. Yeah. Alright, so I understand that. The linked list is held using a pointer, which points to the first item of the linked list called head, and a pointer which points to the last item of the linked list called tail. If that pointer, the tail, is also a null pointer, then the list is considered empty. Let's define a linked list. So here we have, I guess, their own type, so it's not a struct. it is a struct, but the struct is class, so they made their own data type and then had their node called linked list. I don't really know what the public oh wait, public linked list. Oh, that means it can be accessible by anything, or like globally, I think. I don't know. I don't know about that part. Not certain. Then you can call the linked list. Then you have the head equal to null pointer, and the tail equal to null pointer. Oh, so you're assigning the value of the head and tail of this linked list to null pointer, and then in the private, where you can't change the values as easily, you have the node pointing to head and tail, to the value of head and tail. Yeah, so you have the node pointing to the value of head and tail. Adding an item to the end of the linked list. Now we can use the nodes. Let's create a method, create node, to create the first item of the linked list. The process of creating node is as follows. We need a pointer of a node type, which we can define, and we will insert the value in its data field. The next field of node will be declared as null pointer, as it would be the last node of the linked list. Huh? Let's read that again. Let's create a method, create node, to create the first item of the linked list. And the process of creating node is as follows. So you need a pointer of the node, which we define, and we will insert the value in its data. The next field of the node will be declared as null pointer, so that's the last item. There is a special case which we need to check for, namely the linked list is empty. As we know, head points to the first node, which means if head is equal to null pointer, we conclude that the linked list is empty. So if, let's add that as a little note, head is equal to null pointer, linked list is empty, list empty. Okay, if there is just one node which we're going to create in a linked list, both head and tail will point to this element. If a linked list is already created, the new node should be inserted at the end of the linked list. We know that tail points to the last node, therefore the newly created node will be next to the tail is pointing to. Oh, so they're creating it step by step. I see. So that's what they're trying to do. Create this thing step by step. The creation of a new node at the end of the linked list has 2 steps. Linking the newly created node to tail means passing the address of a new node to the next pointer of tail. So linking the created new node to tail. So it keeps going. So the more you create, let's say you create only one node, then this one will be tail, but if you create a new one, it will sort of just push the tail out and insert that node in between the previous one, and it will keep pushing tail. Hello! We are learning currently about linked lists. So, I don't know how to code myself too well, so there's that. But yes, so that's what they're showing here. I feel like this diagram is much better than this one. But I mean, my diagram's a little bit fun, I guess. So we have this linked list. If this one is created, it will simply push tail till after this one. Okay, let's add this method to the linked list class. So we have void create node, and then we have that int value, so that's what they were doing up here. Then we have node, then we have a temporary value, and then you create is equal to the new node, then temp data. So here's where you can just change. Here's where you can just change that value. The visual of head and legs definitely helps. This is This doesn't even look like a leg. But you know, it's okay. It's okay. I feel like this one looks so much better. That's okay. Hold on, I'm gonna take a sip of water. I feel like my voice is starting to go out. Make sure to hydrate. How much more of this lesson do we have? Oh, this is a super long one. Temporary data. So you can reach that data is equal to the new value. Then you go temp to the next one, and then that one will be null pointer. If head's equal to null pointer, and head is equal to the temporary value. That will change this. And tail is equal to temp. Wait, so they're equal to the same value. Oh yeah. Okay, so temporary value. Else, if tail's next, tail to next. So next is the next one. So this is sort of inserting that data. I see. So you're taking a value, you're putting that in a new node, and then you have to sort of push everything to the side. So that's what they're doing here. Yeah, iterating over a list. Let's build a function that prints out all the items of a list. Print list. To do this, we need to use a current pointer that will keep track of the nodes we are currently printing. Keep track of the nodes we are currently printing. After printing the value of the node, we set the current pointer to the next node and print again until we reach the end of the list, the node next to null pointer. Well, let's see, where that print? It doesn't say print. So, same thing as the previous one where they sort of are able to keep adding lists or values to the end of this list, excluding tail. So they insert it between the last value and the tail, and they just add it like that. And then you want to iterate and print it. So you have this function? Yes, this function. Where you take the node and then you point to the current value, which is equal to the head. Or the current value should be equal to the head. So you point back to the front. Yeah, you point back to the front, the value of whatever's in here. Then we go, while current is not equal to null pointer, it will iterate through. Oh, I don't like that. They should have just added the namespace std in the front so that I don't need to add this part. But they're they're iterating through that current node and outputting the value within that node. Yeah. And then after that, so it's, let's say you go through the first one, you are now here, you have outputted this into your little window, and then you need to continue on, so you go current to next, so now you're on 2, and that is equal to current. So we go back to while, and while is not equal to null pointer. It will then output this value of 2, then it will go to next, in which, in this example, up here, oh, you can't see my cursor, can you? Hold on. Can you see it? Oh, you can. Okay, I'll do this. It's very tiny, sorry. But you go to this value, and then it will output this value, then it will go next. So you're now here, then it will output this value, and then you go next, and because this, in this example, the next one is a null because it is the tail or the foot. I should say tail. I shouldn't stick in words that don't actually exist. So the tail, once you're at the tail, it will say that current is now equal to null pointer, and then it will hop out of the while loop and end this function. Insertion. Inserting a new node in the linked list is called insertion. A new node is created and inserted in the linked list. Here, there are 3 cases considered while inserting a node: insertion at the start, insertion at the end, and insert at a particular position. Insert an item at the start, pushing to the list. To add to the beginning of the list, we will need to do the following 3 steps. Create a new item and set its values. Okay, link the new item to the point of the link the new item to point to the head of the list, so we'll point to the head. Set the head of the list to be our new item. Oh, okay. So I'm gonna draw a little flowchart of that as well. We have insert at the beginning. Start. Insert at start. Yeah, insert at start. So we have a value. We'll just draw like the little head again. We have this value. Oh, I could call that 0 actually, to not get confused. We have it like pointing at 1 and then so forth. I'm not gonna rewrite everything. We'll just have it like that and then points. Draw a little box again. And then so on and so forth. So here we can set the head to this value. So now head, so the second part would be, this head part is now equal to, I feel like the faces are getting more distorted over time. Is now equal to 0. But now you want to set the head to the new item. So you want to move the head back. So we'll have like this thing again. And then take this. Have the head sort of go on its own and set it to link and point to the list of heads. Set the head to be your new item. Correct a new head. Okay, and then you kind of like push the head over. Oh, my own head is blocking it. Yes. Sorry, everyone. Oh. Okay, let me quickly explain this. So you want to insert at the start. You have a value. You want to put it like right here. So what you do is have this value equal to the head. So link the new item to point to the head of the list. And then set the head of the list to be our new item. Oh, no, I did this wrong. And then, so you point to the head, and then the head, set the head of the list to be our new item. So you set head is equal to new. But yes, if I am blocking the little screen, please tell me, because I often forget. This will effectively create a new head of the new list and keep the rest of the links of the list linked to it. Since we use a method to do this operation, we want to be able to modify the head variable. To do this, we must pass a pointer to the pointer variable, so we double pointer, lovely, a double pointer, so we will be able to modify the pointer itself. So it requires new double pointer, and I'm gonna put in like, actually that's not the best. Needs double pointer. Yeah, there we go. I think this is right. By the way, this could be a wrong representation, so maybe I'll write this. Maybe. Yeah. Okay. So let's look at the code and see what's going on. So we have the push node. So this is where you start, or you insert at the start. So it's called push node. So you have a node and a new node. So you're pointing to the value of new node. Then you have the new node equal to the new node. So you have new node equal to new node. Then you have this, so this will change that value. Or I should say, you have new node pointing to the address of new node, therefore being able to access the value of new node. Then you are changing the value of new node with this. Then you take the new node, you change, you specifically touch or grab the value, and then you equal that to the new value or the value of the new one. Then you assign the next value equal to head, and then you have head as equal to the new node. Yeah. I'll keep going and see what else there is. Insertion at the end. The insertion of the node at the end is the same as we have done in the node function creation. So that one is this one right here. If you notice, then we inserted the newly created node at the end of the linked list. So this process is the same. Yeah. Alright, so if you know how to add items, you already know how to insert it at the end. So that's nice. Insert at a particular position. The insertion of a new node at a particular position is slightly more difficult. In this case, we don't disturb the tail and head, or the head and tail nodes. Rather, a new node is inserted between two consecutive nodes. So these two nodes should be accessible. I'm tired. By our code, we call one node as current and the other as previous, and the new node is placed between them. The new node can be inserted between the previous and current node by performing two steps. Pass the address of the new node in the next field of the previous node, and pass the address of the current node in the next field of the next node. So, but insert particular position. Particular position. Insert at particular position. Yes. And then you want to pass the address of the new node in the next field of the previous node. So address in the field of the previous node. Oh, I see. So you have to take, you have to, if you want to put, like, let's say you want to put the value of 2 and the new node, you have to put the address in this value right here. So address in previous node of new in previous and then pass the current node the address of the current node in the next node. So you want to push whatever's on the right to the next one, or push. So you want to push whatever's over here. Pretend that it's not a tail. You want to push that to the next one. So pass address, current node, push to next node. Next node. Yeah. Okay. We will access the nodes by asking the user at what position he, she, they he wants to insert the new node. Sorry. It's always interesting when you read engineering stuff. It always usually refers to the person as he. I'm not going to say much about it, but yeah, it's very interesting to see that. Then we will start a loop to reach those specific nodes. We initialized our current node by the head and move through the linked list. At the end, we will find 2 consecutive nodes. Alright, so let's look at this code. So here we have the previous one, the current one, and sort of a temporary storage one. So we have the current is equal to the head. So use a for loop. Previous. So I think that's what pre means. For integer this, you will loop through and iterate through until this is positive, or I is positive. Is it supposed to be negative? I is less than POS. Oh, the value you're taking in. I see. I think I get it. And then previous one is now equal to the current one. Previous value is now equal to the current. The current is next. Oh, yeah, so you're pushing. So the one before, like this one, is now equal to the current in terms of the address. And now the current one, you push that one to the next value. Then you want to reach the data, so you have that data equal value. Then you have previous one to the next. Temporary is equal to temp, then temp is equal to current. I thought that's what you were doing here. But okay, maybe I will learn more if I do the exercise. So right now we're on deletion. So you have become familiar with the linked list creation. I guess so. Not very good though. Now it's time to do some manipulation on the linked list created. Linked lists provide us the great feature of dealing a node. The previous of deletion is also easy to implement. The basic structure is to declare a temporary pointer which points to the node to be deleted. Then a little bit of working on links of nodes. There are also 3 cases in which the node can be deleted. So start, end, and at a particular position. Oh, almost done. Okay, we just need to work on deletion. All right. So at the beginning, let's look at deletion at the front. And I will move the little notes section. After I put this, yes. And deletion at the start, at the end. Okay, take item, take the next item that the head points to and save it. So save item head points to save. So save item head points to. Head points to. Then you want to free the head item. Free head item. And set the head to the next item that we've stored on the side. So head is now next item. Is next item. Yeah, okay. Here's the code. So you want to we have a reset val. Ret val is equal to 0. Then you go to the next node, or you point to the next node, and then you assign that as null pointer. So next node is equal to head points to next. Next node is equal to... the next node is pointing to that next head item. Then you delete the head. And then the head becomes that next item. This one right here. Oh, okay. I actually understand this one, I think. And then deletion of the last item list. Removing the last item list is very similar to adding it to the end of the list, but with one big exception. Since we have to change one item before the last item, we actually have to look 2 items ahead to see the next item is the last item on the list, to see if the next item is the last item on the list. Okay, so deletion of the last item. Deletion at last item. You want to make sure to look 2 items ahead. And it is similar to adding. Similar to adding item. Okay. So let's quickly look at the code. If next item is equal to null pointer, so the next one is null pointer, then you will set this integer value. Oh, is it remove value? Equal to head and the next value. So you get the value of the head, right? Oh, hold on, give me a moment. Let's look back. You go to the head and you have access to the value, remember? Then you delete the head. Then you return. So this is only if there's one item. If there's more than one item, get the second to last node in the list. You have that as your current and you point that to your head. So if current next, oh, you're looking at 2 values, all right? If current next is equal to null pointer, so that means the last, yeah, so 2 ahead, and then keep going 2 times. Then you have the tail, or the end, which is null pointer, and then current is equal to current and next. So taking the current value, taking that next value, and then having that equal the current one. Yeah. Now current points to the second to the last item of the list. So let's remove current next. So you have the temporary one, then you have current points to next, and then you point to that value in the next one. Then you delete that current points to next, so you're saving that value. Then you have current next is no pointer, so you make that the new tail. I don't know if I understand that one, but I'm gonna keep going and let's see what happens. I'm gonna really struggle with this exercise, but it's okay. Okay, removing a specific item. To remove a specific item from the list, either by its index from the beginning of the list or by its value, we need to go over all the items, continuously looking ahead to find out if we reach the node before the item we wish to remove. This is because we need to change the location where the previous node points to as well. So removing a specific item. Let's move this a little bit. And my music stopped again. Why does it keep stopping? Removing specific SP. specific item. Or did it stop? No, I think it did. Okay, I'm gonna be turning that back on. Oh. Here we go. Then you iterate to the node before you want to. How do I say this? Iterate to the node before the node you wish to delete. Iterate through to space before. Honestly, that I think they word it so much better. So iterate through until finds. Iterate through GH. Iterate through till node before. Till node before. Before wanted to node before. Honestly, I think this is fine. Node before to node before deleted, or wanted before deleted. Okay, that sounds fine. Save the node we wish to delete in a temporary pointer. So save deleted node in temporary pointer. In temp pointer. Then set previous node pointer to point to the node after the node. So previous node point to node after deleted. Previous node next pointer and next pointer to after deleted. Deleted. Then delete the node. Then delete node. Delete node. Okay. There are a few edge cases we need to take care of, so make sure you understand the code. I'm going to try my best to understand it. So, remove by index. First you have the integer. Then we have this. And then you have current is equal to head. Okay, so you point to the head. Or current value is equal to the head value. Then you go to node, temporary node, and you have that as a null pointer. You continue, you have whatever n is, so that's your index. Oh, so n is the index, or which number on the list you want to delete. You have the index. If it's equal to 0, then you can just remove pop. You can just remove the head or pop the head. Get rid of the head. They didn't teach us about pop. I feel like I've heard it though. I think pop head means just like straight remove it. But I don't remember. For I is equal to 0, then you have I is less than n minus 1, then you have I plus plus. So if current, then you point to the next one of current is equal to null pointer, then return, because that's the return -1. So now now the value is -1. I don't know. And then current is equal to the next. Oh, it will jump out of this. It will return -1. Okay? And then current is equal to next. So if it's if next is not a null pointer, then the current one's equal to the next one. Yeah, because you want to shift it over. And then you have the temporary node here is equal to current next, so you're sort of saving that node. Then you have this value, and then you take that value of the temporary node. Then you take the value of the next node, or the address of the next node, and then you have it assigned to the current next, and then you delete that temporary node. Okay. So, I'm gonna try to do this. I might fail, but this is the last exercise, so if you do fail, I'm just gonna try to read the solution. But yeah, the last exercise of this little tiny series. I mean, it's a 2-part series, but I feel like I learned a lot, or I practiced a lot as well. So, the example. Last example. You must implement the function. So we have the function remove by value. By value? Why is the R not capitalized? That kind of annoys me a little. Anyways, function remove by value, which removes the first item in the list which has the value. So remove first item. First item, which has the value, and within that it has a value in it. All right. So I'm gonna reference this. Remove a first item. So deletion of the first. Gosh, I really wish I could expand the code so I can look at it all at once. But it looks like I can't. And that's okay. What is here? There's so much stuff. Okay. So here we have the struct. Then we have the linked list, I think. Push node. Linked. Push, yeah, linked list. So here's where it creates itself, I think. Then we have the push node. Pop. Where's this pop coming from? I know that's a term. I feel like that's a term. We have, oh, here it is. Okay. How much more is there? So, how do I think about this? So we want to do this. Right? We want to remove the first item from the list, which has the value. Alright. Last one, I can do this. Okay, what is everything named? Let's see, we have next, temp. Popping from linked list. Oh wait, that's what it's called. But why would you need me to code it? If you already have a pop function, which is where you remove the first part of the linked list. Very interesting. So it's gonna be kind of like that, I assume? But it's gotta be different, or else why would they ask me for it? Let me think a little bit. I'm using 1,000% of my brain power. But it's not... Okay, first let's start easy. Let's start at the edge case where... Well, let's say... the head is null, because if the head is null, then there's no need to, because then the list is empty, right? So let's first start there. So how do they do that? Up here? I can go if head is equal to null pointer, then I can just jump out of this. I can jump out of the function. So isn't that like a return? And return 0 won't work here because this is a void. So we just want return. Return. And question marks. Need the question marks there. Then what? But I don't... Does the pop function ever get called? Because I feel like, couldn't you just call the pop function? I don't really understand. I mean, I know that's not the point of this, but still. So, remove by value 3. So that's what it's calling. It's calling value 3. So I guess I don't have to worry about that value being done or being removed. So let me think. Does anyone know, chat? I'm gonna need a little bit of help if anyone can help. What I'm supposed to do is implement the function remove by value, which removes the first item in the list, which has the value. Oh, it's not the first item in the list. It's the first item that has the value 3. I get it now. I misinterpreted this question. First item has value 3. I see. I get it. I understand what it's asking now. Okay. I got a little bit distracted. It's fine. So, I need to remove if it has that value. So if the head has that value, then I can just pop out the head, right? Okay, I see. So if... Whoa, what did I do? I pressed the button on accident, my bad. Didn't mean to do that. So it's sort of like, you have to remove it at the beginning and at the end, and so you have to combine all 3 of these, and I'm starting to get it. But pop already exists. And so does remove last also exist? Push node, create. Okay, so no, it doesn't. But where was it? I lost it. I lost where I was typing. Oh, right here. So we'll go with the first, and then we'll see. So if head value, right? So I have to retrieve the value, is equal to if head value is equal to the value that the input that means that I can call the pop function And then I can jump out of this. I can just simply return that. Where's the pop function? I lost it. Pop should have its own return. Oh, thank you for the follow! I'm almost done with this, I think. Actually, maybe not. I don't know. If you know how to do linked lists, please help. I don't know what I'm doing. Then if... What do I think about this? Then I have to shift, right? I have to shift it, so removing a specific item. Something like this. Which removes the first item, which the value, which has the value. How do I do this? Think use 100% of my brain, or 10,000% of my brain power. How do I do this? Remove the first item which has value 3. So I need to iterate through the list. I have to iterate through it. And how do I do that? I can do this for loop thing. Right? I can do this for loop thing. So... Wait, but no, I can't. I don't have an integer n. I just have int value. So if... Okay, let's copy this. So I can put another if statement and go if whatever I'm on, I need to find out how to iterate this. If my current value is equal to my value that I put into the function, then that's the one I have to delete. I gotta do something here. Current value. Then I want to delete the current value. Right? If my current value is equal to value, then I want to push my previous one to the current one. Okay, I know I have to delete current or something. Then I have to take that current one that I want to delete and change it. I have to swap it out. But how do I do that? Oh, speaking of current, I need to declare current as a part of this at the beginning, right? I have to declare it. You think so? Node check. Pointer current. And I also need head. Head? Value? No, head is an actual thing. Never mind. Leak code style problem. It's so yesteryear. It wouldn't be more fun to try to write a game. You see, I'm very bad at coding and I just started. This is not a leak code problem actually. Leak code problems I'm pretty sure are much harder. I'm trying to learn. I just started learning, really. Not ready to code a game yet. And I think these problems are really nice and fun to like follow along. But maybe one day I'll make a game. Or try to make a game. Just a day is not now or not anytime soon. Yeah, I'm certain that this problem is much easier than your average leak code problem. So if you know what leak code is like practice coding problems that people do. And I'm pretty sure they're very difficult. This, on the other hand, is probably not that difficult. It's just, I don't know what I'm doing. So yeah. But however, if you would like to help me solve this problem, that would be much appreciated. So, I'm doing like this. And I need to remove the first item that has a value of 3. So far, I'm writing this function and this function only. So I've declared pointer to current. Then if the head of it is a null pointer, that means it's empty, so I'm going to jump out. However, if the first value, which is the head, is equal to the value that we want, then I'm going to pop out to that first value and return, and I'm stuck on this part where it's not at the beginning. I definitely know that I have to iterate through the linked list, but I don't know how. I would if I knew how. Thank you, though. I appreciate the sentiment, because sometimes it's hard to talk to myself. I feel like an insane person. But, what's new today? Nothing. I don't know what to do. That's if I do at the last part of the list. So I have to take the previous one. Okay, let me bring back that little diagram. Yeah, this little diagram will help me. My English is my second language. Wow, really? I'm so impressed. I love people. Well, people who speak English, or not English, people who speak multiple languages always impress me. And I've always wanted to become one of those people, but unfortunately I'm not talented in linguistics. You need to iterate until current value is 3. Yeah, that's the problem. I don't know how to iterate through it. And then you set current next is equal to current next. Isn't that only when you want to remove something? Huh. First, I need to know how to iterate through, though. That's the problem. I was thinking of using like a for loop, like what they've shown here, but I don't think that's right because I have a specific index to remove. However, I'm not given that index, so. Or could I make a for loop, have value as this part, or I can just take out that part, and then have the condition if current value is equal to this. Then I will jump out of it and try to do it. I don't really know. What to do? I think you just... Oh, sorry, you just need to delete by index, not by value. Delete by index? Delete by index? You mean I need to find which index has that value? So... Let's try this. I have 4. Then I need to find the index that has that value. So I can have 0 as, or my I as my counter, and I can put 4 I is not. Oh no. No. The current value is not equal to value. Then I will just keep on increasing. Yeah. I'll keep on increasing that, and then once I get I. So once current value is equal to value, I now have that index. Right? Yes. I don't even need this. I can just do this, I think. I don't actually need anything in the for loop. I don't know if that's allowed. Let's try that. I'll keep looping, then current is equal to current value. So I'm going to delete that if statement. Then we can just copy this part. Oh, I need to declare int I. I'll copy this. The little lesson part. Okay, I'm gonna try this like twice, and if I can't get it, I am quite tired, so I may just look up the solution and try to see what's going on. Let's try this though. If current value is that. Oh wait, no, I can't. Because I have to go current next. And current is, it's written for me. I could have just copied this. I'm just gonna press return. Current next, and then I can do that. And I don't think I need this, so I'm gonna delete that as well. Return. If the head one is equal to it, then I can just pop the value out. Oh, but it might go through both. I don't want that. Oh wait, but I do have a return, so that's fine. I think that's fine. Let's try running this. Was not declared. Oh, so I did need that. Never mind. My bad. I did need the retval. The reval. I don't need that twice. So that's probably not right. And why is it outputting some stuff? All the way at the bottom of this. What's going on? Why is it so long? Oh, here it is. What? I can't go to the bottom? I just want to see the bottom. What is it printing? Oh no. This may be a problem. At least, I mean, actually, no, that's not good. I'd rather have a syntax error than this. Okay. Print list. Remove the second one. Oh, so the output's supposed to be 1, 2, and 5. But I have it flipped, so I'm removing the first one. But it's also flipped. That's not right. Next. When you remove by value, all you need is so node pointer head, so that would be my current, while p if p next value is equal to value, then hold on, p's next value, then break. Oh, break is a good one. That's what it was supposed to be. No, that's break. Never mind. No, break is for the loop. Ignore me. But you also need to take care about edge cases. Oh, right. Okay, so I have the first edge case, if the first one is. And I also have if it's null pointer. So I have those two edge cases down. Then, okay, I'm gonna try yours. I'm gonna delete this. Oh. You remove all values you will need. So I think while current, which is my p, so current, while current. Wait, what's the thing? Oh, you're just gonna have that as always going. Oh, you're gonna use break to jump out of the loop. I see. So you're not actually gonna use a condition here. So can I put just like while 1 instead? While 1. So if current next, not nest, next, then you have value is equal to value equal to value. So that's your condition, okay. So current one, you go next in the value. Okay. If current next value is equal to value. So you're on the current one, you're pointing to the next one, and then you're getting the value of this. So that's 2. Then you set current next equal to current next current next, and then next. No, current ends when current becomes... Oh, null pointer. Right. Okay. I see. It's not endless. That's true, because what if there is no value? What if it's like you give it a value and it doesn't end? I was thinking like, oh, one of them has to be, right? So we'll just break the while loop. But yes, you're absolutely correct. There may not be a value. And once the end of the list is done, then you should jump out of the loop. So if it's equal to that, then current is equal to the next one, because it shifts over. Yeah. Okay. Current next. Okay, let me try to rethink about this. So we have current. It will loop through unless the list is over. Then we look at let's see, the third one. So we have one. Okay, so we have the one value. Then we look at the next next value. So that would be 2. And if that one is equal to whatever value the user puts in, then the current next, which is this entire one, 2, will be equal to the next one, to the next, because you're pushing it over. Okay, and then the current value is now, which was 1, is now equal to the next one. But does that delete it? I think you have to delete it. You have to delete the previous one. So do you need a previous one? Hold on, let me think a little. The previous one could be... I have to delete it somehow. What if I have a previous? Or... Oh, where'd you go? Or I can have a temporary. I can use the temporary one as the previous one. As a placeholder. You actually don't need to delete. It'll work? Oh, really? You sure? Well, let's try it. See what happens. Huh? Is it stuck? I think it may be stuck in the loop. Okay, how do I not pause? Stop! I don't know how to stop this. So, what I'm gonna do is I'm gonna copy and paste this and reset it. Hit copy. Okay, reset. Executing. No! Start exercise. Uh-oh. I think we may have broken the site. I think we may have broken it. Oh wait, I pressed the solution. Oops. That's fine. I did not see it. I promise I didn't see it. Let's try that. We engineered too hard. Exactly. No, I didn't. It's still executing. It's still executing. Uh-oh. What if I refresh? Hold on, I'll be back. I mean, I'm not gonna go anywhere, but let me hide this for a second. All right, refreshing has fixed it. I have a feeling it got caught in the loop somehow. And it couldn't exit out of it. We could just look at the solution. I'm gonna try one more time, and then if we don't get it this time, I'm just gonna look. I'm a bit tired, not gonna lie. So how? Oh, I didn't add break. I'm so stupid. I did not engineer hard enough. That is why I didn't add break. Right. All right. Uh-huh. Okay, let's try this again. That was me. That was my bad. Oh, it's right. Hold on. Okay, I want to see what's happening. But how come you don't have to delete the current one? If you're still here, could you explain to the class? Because I don't know what I'm doing. I forgot to add break, and I'm so sorry. So if you have, so I have the edge cases, whatever, if it's empty or the front. And then you have, where'd it go? While loop, not that one. Right here, current, while loop. So it will loop through the entire linked list. Linked list until it will find a value where it equals. Yeah. So it will find a value where it equals, and then it will take the current next one. So we'll say like 2, and that will equal now that current. So 2 will now equal 3, or space 3. Oh, this is a good time to draw it out. Engineer 101, it just works. It's so true. You know, if it's not broken, don't fix it. Okay, where is my mouse? There we go. Or my little icon. So we have the loop. It will iterate through. Then we have if current next one. So we have, let's call this circle 1, 2, 3, 4, like 5. I don't know how many more I have of these I have to make, but I think that should be enough. So let's say the current one is 1. So you go next value, which would be 2. I'm gonna pretend that the address doesn't exist. So we're now here. Right, so I've already checked this one. Okay. And then, so now we're here, and if we'll check if this is equal to the value. Let's say that it is. Let's say that the value is 2. So when the value is 2, so the current one. Okay, so the current one is still this, right? So this is still current. Well, we'll name that C for current. This is current next. So current next value. So we'll call that like C and V. Then we will label that. Oh, actually, the V is not very necessary. I feel like that might confuse. Just know that this is the value. And then, so current next, which is this, is now equal to CNN. Okay, so now this one moves there. So now it looks like this. So current next. Oh, it's so you don't need to delete this. You like this doesn't need to be deleted. It will just remove itself. But will that cause like a memory leak or anything? Because it's sort of just like there, it's floating. I guess now that becomes this, so it just becomes 3. I don't know what happens to the 2. And then continues on with 4, 5, and whatever. And then the current one, which is this one, now becomes this one. I see what you did. Thank you so much, by the way. I really appreciate. Oh, my giant head is still blocking the whiteboard. Hold on. My bad. My smooth brain giant head is still blocking the whiteboard. So we have current, then we have current next, and then we reassign current next, which is this case, into this value. So it becomes there. But nothing happens, so you don't need to delete this. All right. Well, this is a very interesting lesson, but oh, the music stopped again. I guess this is a good time to end the stream. But yeah, thank you so much, everyone. You know, if you want to like and subscribe or follow, whatever, or if you want to go to the purple site and look there, that'd be greatly appreciated. But yeah, thank you everyone for coming. I really appreciate it, and thank you for helping me out. Even if you don't help me with coding, you know, emotional support exists. Making me laugh and emotional support exists. So that was very helpful. But yeah, I really appreciated it. And thank you for coming to my last stream before my hiatus. I'll see everyone back in October. And it's spooky season, so I will be torturing myself by playing horror games and maybe doing more math and more coding stuff, because, you know, what's more terrifying than that? But as always, we're gonna find someone to raid on Twitch. And yeah, spooky month. I'm excited for spooky month. I have a few games that I already I bought, and I think I'll do another demo showcase in October as well. So let's do that. Oh, this Sukiyaki is on. I'm gonna raid Sukiyaki. They are playing Cult of the Lamb. But yeah, that will be where we're raiding to. But once again, thank you. Make sure to take care of yourself. If you'd like to join the raid, feel free, and if you don't, that's totally fine too. But I will be pasting the raid message into both. But yeah, okay. I'm gonna switch to this screen, and we will begin the raid in around 10 seconds. So, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Beep boop. Bye, everyone!